Okay, in this video we're going to be going over the study guide for the final exam, and the problems that I go over in this video will be similar to the ones that you will see on the actual College Algebra final exam, and you will have a help sheet with the information that you're going to need in order to work some of these problems out that you'll see in this video for this study guide. We'll begin with problem number 1, where you have to solve the linear equation x minus 3 divided by 3 plus x plus 5 divided by 2 equaling to 19 divided by 6. So what I'm going to do here is just rewrite that original problem. And notice that we got fractions in the denominator, pretty much whole numbers, not fractions. It's written in a fraction form, but it's whole numbers in the denominator. So we need to get rid of those whole numbers by multiplying each and every term by what they call the least common denominator of 3, 2, and 6. And in this case, it's going to be 6. So we're going to take each and every term of this equation and multiply it by 6. That way I can eliminate all these fractions and come up with an equation that has no fractions in it, and I can easily solve for x. So for this first term here, where you got 6 times x minus 3 over 3, I can divide 3 into 6. That's going to go 2 times. So that means I'm going to have 2 parentheses x minus 3. And then plus, for the 6 times x plus 5 over 2, the 2 goes into the 6 3 times. So now you got 3 parentheses x plus 5. That's equal to, then these 6's divide out, where you got 6 times 19 over 6. That'll give you 19. So now you got 2 parentheses x minus 3 plus 3 parentheses x plus 5 equaling to 19. So here I got an equation that I can easily solve for x. Now on the left side, I can use the distributive property. So here if I do 2 times x, that will be 2x, minus 2 times 3, that will be 6. So that's 2x minus 6, plus 3 times x, that will be 3x, plus 3 times 5, which will be 15. And that's equal to 19. Okay. So now we're going to combine like terms here. 2x plus 3x. That will be 5x. Minus 6 plus 15 will be a plus 9. So I have 5x plus 9 equaling to 19. Now I need to get that x by itself. Well, get the 5x by itself. I'm adding 9, so I need to subtract 9 on both sides. So that'll be 5x is equal to 10. And now I can get the x by itself. I'm multiplying by 5, so I need to divide by 5. So that means x will equal 2. So x equals 2 is the solution to that linear equation. Now you're not required to do the check on the exam. If you had the time, you could do the check by just replacing each x in the original equation with the 2. To find out if the left side does equal to the right side. Alright, problem number 2, we're going to be multiplying complex numbers. Here we got 3 minus 2i, and it's being multiplied by 4 plus 5i. So here we got 3 minus 2i multiplied by 4 plus 5i. Alright, in this case here, we're going to have to use the FOIL method because we're multiplying 2 complex numbers that are written in standard form. And also, when you multiply complex numbers, any occurrences of I squared, you must replace it with -1. So let's go ahead and start by using the FOIL method here. First term times the first term, that's 3 times 4. That would give you 12. outside times the outside, 3 times 5i would be a plus 15i. Your inside terms, multiply those minus 2i times 4, which will be a minus 8i. And then the last term times the last term, minus 2i times a plus 5i will be a minus 10i squared. Because then minus 2 times the 5 will give you the minus 10, and then I times I will give you I squared. Now, as I mentioned earlier, you have to replace your I squared with negative 1. Okay, so what I'm going to do here is rewrite this as 12 plus 15i minus 8i, and then this minus 10, the I squared will be replaced with negative 1. Okay, so the next step would be bring down the 12. 15i minus 8i would be a plus 7i. And this negative 1 will make the minus 10 plus 10. So now if I add 12 plus 10, that's going to give me 22 plus 7i. So here the product of those two complex numbers will be 22 plus 7i. Okay, problem number 3. Here we're going to solve by using the quadratic formula. And that's x squared minus 2x plus 17 equaling to 0. X squared minus 2x plus 17 equaling to 0. Okay, notice that I do have a 0 on one side of the equation, so this is written in standard form. So I can use the quadratic formula by identifying a, b, and c. The a is the coefficient of your x squared term. That's 1. The b is the coefficient of your x. That's negative 2. Your c is your constant. That's going to be 17. Okay? And of course our quadratic formula is going to be x is equal to negative b plus or minus the square root of b squared minus 4ac, and all that's divided by 2 times a. Okay, that's the quadratic formula. Now we're going to substitute the values of a, b, and c in this quadratic formula. Well, b is negative 2, so we got this negative in front of the b, so that's negative of a negative 2 plus or minus the square root of. B is negative 2, so that's going to be a negative 2 square minus 4 times a, which is 1, times c, that's 17. Now that's divided by 2 times a, but a is 1, so the denominator will be 2 times 1. Okay, now let's go ahead and simplify all of this. The negative of a negative 2 will be a positive 2. So I'm going to have 2 plus or minus. Now underneath the radical, the square root of, negative 2 squared is negative 2 times negative 2. That will be 4. Minus 4 times 1, which is 4. 4 times 17 will be 68. So underneath the radical, I have 4 minus 68. And all of this will be divided by 2 times 1, which will be 2. Okay. Continuing with this problem, we got 2 plus or minus. Underneath the radical, we need to simplify 4 minus 68. That's going to be negative 64. So I have 2 plus or minus the square root of negative 64 all over 2. Now the square root of negative 64. I know the square root of 64 is 8, but I got a negative sign, meaning that there's negative 1 in this underneath the radical. So the square root of negative 1 will be I. So the square root of negative 64 is 8i, and all that's going to be over 2. So you have 2 plus or minus 8i over 2. And I'm going to go ahead and split this up as 2 over 2, and then plus or minus 8i over 2. Now, if I do 2 divided by 2, that's going to be 1, and then plus or minus 8i divided by 2, that's 4i. So my final answer there will be 1 plus or minus 4i. And that means I have two solutions. 1 plus 4i. The other one will be 1 minus 4i. Okay. All right, problem number 4. Here we're going to solve this equation by factoring. In this case, you got x cubed minus 14x squared plus 48x equaling to 0. And we're going to solve that equation by using the method of factoring. Alright, in this case here, we're going to have to first find the common factor that's in x cubed, 14x squared, and 48x. Each one of them has an x in this particular problem. So we'll use the x as the common factor. That will be on the outside of the parentheses. And when you find your common factor, you find the common variable that has the lowest exponent. And it's going to be, in this case, x to the 1. So let's use x as your common factor. Now, to get what's inside the parentheses, we're going to divide each term by that common factor. So x cubed divided by x will be x squared. Minus 14x squared divided by x will be a minus 14x. Plus 48x divided by x will be 48. And that's equal to 0. So I get x times x squared minus 14x plus 48 equal to 0. Now for the x squared minus 14x plus 48, I can factor this into two binomials here. So I'm going to bring down the x. And factor the x squared minus 14x plus 48. Well, x squared will be x and x. And then the factors of 48, that will give me a middle term of 14 minus 14x would be minus 6 and a minus 8. So it would be x times x minus 6 times x minus 8 equal to 0. And this is factored completely. Now, we need to set each individual factor in this equation equal to 0. So x times x minus 6 times x minus 8 equal to 0 means x is equal to 0, or x minus 6 equal to 0, or x minus 8 equal to 0. Now for each individual equation we're going to solve for x. Well, the first equation is already solved for x. That's your x equals 0. Now for the x minus 6 equal to 0, if we add 6, that means x is equal to 6. Or for x minus 8 equal to 0, if we add the 8, you're going to get x is equal to 8. So if your x equals 0, x equals 6, and x equal to 8 will make this expression equal to 0 when you substitute those values in for x. So the solution set would be 0, 6, and 8. Okay. All right, problem number 5. Here we've got a radical equation that we're going to solve. And this one you're going to have to do the check on the solution here. Here we've got the square root of 5x plus 14 equal to x. Square root of 5x plus 14 equals x. Okay, so we're going to solve this radical equation. Notice that the radical is already by itself. It is the square root of 5x plus 14. So the opposite of taking the square root would simply mean we need to take the square. on both sides. Opposite of the square root is taking the square. And when you square both sides, the radical on this side is eliminated. So the square root of 5x plus 14 and u squared would be the 5x plus 14. And that's equal to x and u squared will be x squared. So now I have a quadratic equation because of the x squared. What I'm going to do here is move the 5x and the 14 over to the opposite side where that x squared is. So here, the x squared will remain on the right-hand side. But when I move that 5x over to the right-hand side where that x squared is, that's going to become minus 5x. And if I move that plus 14 over to the opposite side, it will be minus 14. So now I get x squared minus 5x minus 14 equal 0. Now let's factor that x squared minus 5x minus 14 into two binomials here. So here, the x squared would be x and x. Now the factors of negative 14 that would give me a negative 5x as a middle term would be plus 2 and minus 7. Because 2x and a minus 7x will give me a minus 5x. So factored completely, I have x plus 2 times x minus 7 equal to 0. And then I'm going to set each binomial factor equal to 0. So x plus 2 times x minus 7 equals 0 means this. X minus 2 equals 0, or x plus 2 equals 0, I'm sorry, or x minus 7 equals 0. Okay. Now for each equation, I'm going to solve for x. So for the x plus 2 equal to 0, if I subtract 2, I'm going to get x equals 2. Or for the x minus 7 equal to 0, if I add 7, I'm going to get x equals 7. Wait a minute. X plus 2 equals 0, that means x equals negative 2. Okay. And then the other one would be x equals 7. So negative 2 and 7 are my proposed solutions for this radical equation. Now I got to do the check for each one of these. I'll start with x equal negative 2. So using the original equation that I got, I'm going to replace the x with negative 2. So the square root of 5 times negative 2 plus 14, that should equal to negative 2. Here, each x in the original equation, I'm replacing it with negative 2. Simplify the left-hand side, and underneath the radical, 5 times negative 2 will be negative 10 plus 14. That's equal to negative 2. Now, if I add negative 10 to 14, you're going to get 4. So the square root of 4 should equal negative 2. And when I take the principal square root of 4, that's going to be 2, which is not equal to negative 2. So that's a false statement. So I can exclude x equals negative 2 as the solution to that radical equation. That's one of our extraneous solutions. I also got to do the check for x equals 7. In this case here, replace each x with 7, so we have the square root of 5 times 7 plus 14. That should equal to 7. And underneath the radical, if I do 5 times 7, that's going to be 35 plus 14. That should equal to 7. And then 35 plus 14 would be 49, so the square root of 49 should equal to 7. And if you take the principal square root of 49, you would get 7. And 7 does equal to 7, so I do have a true statement here. So that means that x equals 7 is the solution to that radical equation. And that's the only solution to that radical equation. Okay. Alright, problem number 6. Here we got the absolute value of 2x minus 5 and then plus 4 equaling to 11. Alright, in this case here, I want to first get the absolute value by itself. That absolute value 2x minus 5, I need to get that by itself. I'm adding 4 to it, so I need to subtract 4 on both sides. So here you got the absolute value of 2x minus 5, and that's equal to 11 minus 4, that would be 7. So here the absolute value is by itself. So now, with the absolute value of 2x minus 5 equaling to 7, I can go ahead and write this as two separate equations. One of which would be 2x minus 5 equals to positive 7, or the other equation would be 2x minus 5 equaling to negative 7. So here, each one of these, I'm going to go ahead and solve for x. Starting with the 2x minus 5 equaling to 7, if I add 5, that means 2x is equal to 12. Divide both sides by 2. You're going to get x is equal to 6. So here x equals 6 is a solution to that absolute value equation. And for the other solution, this is going to come from the 2x minus 5 equal to negative 7. So here if you add 5 to both sides, that means 2x is equal to negative 7 plus 5 will be negative 2. Divide by 2. X is equal to negative 1. So in this case here, x equals negative 1 and x equals 6 are the two solutions to that absolute value equation. Okay, onward to problem number 7. Here we're going to solve the inequality of 7 parentheses x minus 8 plus 3, and that's less than 6 parentheses x minus 5 plus 3x. Okay, in this case here, we need to simplify the left side and the right side by removing parentheses and combining like terms. So on the left side, using the distributive property, you got 7 times x, that's going to give you 7x, minus 7 times 8, that's 56, and then bring down the plus 3. It's less than. The right side, using the distributive property again, 6 times x, that's 6x, minus 6 times 5, that's going to be 30, plus 3x. Now let's combine like terms on both sides. On the left side, I'm going to bring down the 7x. Minus 56 plus 3 will be minus 53. So I have 7x minus 53, and that's less than. 6x plus 3x will be 9x, and then bring down minus 30. So you got 7x minus 53 is less than 9x minus 30. Now the next step would be to get the variable on the left side of this inequality. It's much easier to work with this particular inequality by putting the variable on the left hand side. So I'm going to move the 9x over to where the 7x is. And I'm going to do that by subtracting 9x on both sides. So in this case here, 7x minus 9x is a negative 2x. Minus 53, that's less than, bring down, negative 30. So you got negative 2x minus 53 is less than negative 30. Now to get this negative 2x by itself, I'm subtracting 53, so I need to add 53 on both sides. So here I'm going to have a negative 2x is less than, negative 30 plus 53 will be 23. So I got negative 2x is less than 23. And then I'm going to divide both sides by negative 2 to get x by itself. But when I divide by negative in an inequality, or multiply both sides of an inequality by a negative number, this inequality symbol changes from less than, in this case, to greater than. So when you're multiplying or dividing both sides of an inequality by a negative number, your inequality symbol reverses to the opposite direction. And I'm going to leave that as negative 23 over 2. So the solution set will be x is greater than negative 23 over 2. Okay, problem number 8 is an absolute value inequality. In this case here, you got the absolute value of 2x plus 13 is greater than 7. Absolute value of 2x plus 13 is greater than 7. Alright, in this case here, I'm going to have to apply the rule that where you have the absolute value of x greater than some constant, you have to write this as two separate inequalities. X is greater than that constant itself, or x is less than the negative of that numerical constant. So that rule here will be applied here, because I got the greater than symbol here. So absolute value of 2x plus 13 is greater than 7 means x plus 13 is greater than positive 7, or 2x plus 13 is less than negative 7. Okay, now for each inequality I have to get x by itself. So here for the 2x plus 13 is greater than 7, if you subtract 13, that means you're going to have 2x is greater than 7 minus 13, that's negative 6. And then divide both sides by 2, that means x is greater than negative 3. And then for the other inequality, 2x plus 13 is less than negative 7. If I subtract 13 on both sides, that means that 2x is less than negative 20. Then divide both sides by 2. That means x is less than negative 10. So my solution set for this absolute value inequality will be x is greater than negative 3, or x is less than negative 10. Okay. Alright, now problem number 9. Here we're going to select the graph of a relation which is not a one-to-one function. Now, let's think about this. For a one-to-one function, you cannot have a y value being paired with two different x values. So if you look at graph A, you see each individual y value is paired with only one x value. So A is one-to-one. If you look at B, 5 is paired with 1, 11 is paired with 1, 38 is paired with 17. That's a one-to-one function. Now look at C. 1 is paired with negative 3, but notice that 3 is paired with negative 4 and negative 1. You got a y value paired with two different x values. So here, graph C is not a one-to-one function. Okay. All right, problem number 10. Evaluate the function f of x is equal to 3x plus 9 if x is less than 1, or x squared plus 1 if your x is greater than or equal to 1. So you're going to be evaluating this piecewise function when x is equal to 5. Okay, so in this case here, we're going to have to figure out which one of these we're going to have to use based on the fact that x is equal to 5. And then will have to be the second one, the x squared plus 1. And that's because 5 is bigger than 1. So here we're going to be evaluating f of 5 using the x squared plus 1. And x will be replaced with the 5, so it'll be 5 squared plus 1. Now 5 squared is 5 times 5, that's 25. 25 plus 1, that will give you 26. So the value of that piecewise function at x is equal to 5 would be 26. Okay. All right, problem number 11. Here we're going to find the domain of the function f of x is equal to 18x squared plus 123x minus 203, all divided by x squared plus 5x minus 24. In this case here, we have a rational function because we have a numerator and a denominator. So we want to find out what values of x that will cause this denominator to be equal to 0. So what we'll do here is set that x squared plus 5x minus 24 to be equal to 0. Okay? Because that value, whatever those x values are, that's what's going to make that denominator 0. Okay? So now we'll take that x squared plus 5x minus 24 and factor that completely into two binomials. So in this case here, your x squared would be x and x. And then factors of negative 24, that will give me a middle term of 5x will be, let's see, plus 8 minus 5, minus 3. Plus 8 and a minus 3. And that's because 8x and a minus 3x will give me the middle term of 5x. So this is x plus 8 times x minus 3 equaling to 0. And then we set each binomial factor equal to 0. So this means x plus 8 equals 0 or x minus 3 equals 0. And then for each equation, we'll solve for x. So for the x plus 8 equal to 0, we subtract 8. You're going to get x equal negative 8. Or for the x minus 3 equal to 0, that means x is equal to 3. So for x equal 8 or for x equal 3, you're going to get a 0 in the denominator. Those are the values of x that will make that denominator 0. So the domain of that rational function is this. And I'm just writing this in set builder notation. That's the set of all x such that x equals negative 8 or x equals to 3. So the domain is all values of x such that x is, and I should say not equal to, for each one of those, not equal to. Not equal to negative 8 or x is not equal to 3. Problem number 12. Here we're going to use the slope and the y-intercept to graph the equation f of x equals to 3/4 x minus 5. So here you have to know slope-intercept form, and that equation is in slope-intercept form, which is, of course, y is equal to mx plus b. M is always the slope. The b is the y-intercept. Your slope is always the coefficient of the x term. The b is the number added to or subtracted from. That's your y-intercept. Okay. Now looking at this, it is in slope-intercept form. So the slope is this number that's in front of your x. That's going to be 3/4. The b, the y-intercept, that will be -5. Okay. Now the next thing I'm going to do here is use this piece of information to make that graph. First of all, we plot the y-intercept of -5. That's the point where the graph crosses the y-axis. So here on the y-axis, I'm going to go down to 5 and draw the point. Now I'm going to use the concept of rise over run to get my second point, using the slope of 3/4. That 3, which is your numerator, that's your rise. The 4, which is your denominator, that's the run. So starting from the y-intercept of 5, the rise is 3, so that tells me how many places I need to go up or down from the y-intercept. In this case, it's 3, so I'm going to go up 3 units from the y-intercept. I'm going up 1, 2, 3. The run tells me how many places I need to go either to the left or to the right. The run in this case is 4, so I'm going to go to the right 1, 2, 3, 4. And this is where my second point will be, right here. So using rise over run, I rise up 3 and to the right 4. Now, I'm going to connect those 2 points that's on the graph, like this. Now I'm going to go ahead and draw the line that passes through those 2 points. And that line represents the graph of the linear function f of x equals to 3/4 x minus 5. Okay. Now problem number 13. It's a transformation of functions here. So here I'm given the graph of f of x. And I want to make a graph of the function f of the quantity x plus 5 minus 3. So I need to find out what type of transformations do I have here. Well, notice I got the plus 5 next to the x. So that tells me I have a horizontal shift. And then I got that minus 3 on the outside. So that tells me I have a vertical shift. Okay. So here I have 2 transformations, the horizontal shift and the vertical shift. Now, based on the sequence of transformations, I have to do the horizontal shift first and then do the vertical shift. Now, if you didn't know that right off the top, you always do your vertical shift last. And you can also think of this. You're taking the value of x, you're adding 5 to it. And then whatever this is, you're going to subtract 3 from it. So it's obvious you have to do the horizontal shift first, and then the vertical shift last. Okay? Now I'm going to write down my ordered pairs for f of x. And in this case here, my ordered pairs, by looking at this, this will be 3, 7. Then my second point will be, what, 7, 2. The other point would be 9 and up 5. So those are my ordered pairs for f of x. Now I do have the horizontal shift. I'm going to abbreviate h shift. Now it says here add 5, but with the horizontal shift you do the opposite of adding 5 in this case. That's subtracting 5. Now I'm going to be subtracting 5 from each x coordinate because it is a horizontal shift. anything horizontal means the x-coordinate is changing. And then for the vertical shift, anything vertical means that the y-coordinate is going to change. It says -3, so I'm going to do exactly what it says here. Subtract 3 from each y-coordinate. Okay? And then whatever I get in this last column represents the ordered pairs for g of x, which I will plot on the coordinate grid. So what would the ordered pairs be after doing the horizontal shift? Alright, let's subtract 5 from each individual x-coordinate here. So here, for 3, 7, if I do 3 minus 5, that's -2. Then I'm going to bring over the 7. For the second point, 7, 2, if I do 7 minus 5, that would be 2. Then bring over the 2. And then for 9, 5, 9 minus 5 will be 4. And bring over the 5. And now for the vertical shift, use these ordered pairs to come up with new ordered pairs after doing the vertical shift. You're going to subtract 3 from each individual y-coordinate. So the x-coordinate will remain the same. I'll bring over the -2 for this first point. If I do 7 minus 3, that's going to be 4. The second point, bring over the 2. If I do 2 minus 3, that will be -1. And then for this last point, bring over the 4. If I do 5 minus 3, that would be 2. So these ordered pairs in this last column are going to be what g of x is going to look like. So I'm going to plot these ordered pairs on the coordinate grid. Starting with -2, 4, go to the left 2 and up 4, draw that point. 2, -1 will be to the right 2 and down 1, draw that point. 4, 2 will be to the right 4 and up 2, and draw that point. So here I'm going to connect those dots in the same order as the graph of f of x. So that's the graph of g of x equaling to f of x plus 5 minus 3. Now in this case here, this is the same as this graph here. The only thing that's different here is that this graph has shifted to the left 5 and down 3. Okay, so that's problem number 13. Alright, problem number 14. We got two functions, f of x and g of x. And in this case here, you got f of x equal to 3x minus 1, and g of x is equal to -7x plus 2. And we want to find f minus g of x. So here, f minus g of x means this. F of x minus g of x. So here we're subtracting the two functions here. My f of x in this case is 3x minus 1. And then minus, my g of x is -7x plus 2. But here, I'm going to put the -7x plus 2 inside the parentheses. That's because I'm subtracting the entire g of x function from f of x. So you have to put -7x plus 2 in the parentheses. Now let's simplify this. Bring down the 3x minus 1. Now that minus sign will make the -7x plus 7x. And that minus sign will make the plus 2 minus 2. So here I'm distributing the negative over the -7x and the plus 2. Now combine like terms here. 3x plus 7x is 10x. Minus 1 and a minus 2 will be a minus 3. And that's as far as I can go with that problem. So f minus g of x, which is f of x minus g of x, will end up being 10x minus 3. Alright, problem number 15 is the composition of two functions, f of x and g of x. Well, the composition of f with g of x. In this case, your f of x is 2x plus 5. G of x is x squared minus 7. And we want the composition of f with g of x. Sometimes we call that f circle g of x. Okay? And that means f of g of x. That's basically what that means. My inside function is g of x. G of x in this case is equal to x squared minus 7. So, I'm going to replace the g of x with that x squared minus 7, because that's what g of x is equal to. So, I'm going to be evaluating f of x squared minus 7. Well, I'm going to write down what f of x is. My f of x is given as 2x plus 5. So in this case here, this x will be replaced with what g of x is. That's your x squared minus 7. So in what f of x is, that x will also be replaced with x squared minus 7. So case in point, when you're finding the composition of f with g of x, you're basically taking your g of x function and putting in place of each and every x in the f of x function the g of x function. So each x in f of x, you're going to replace it with whatever g of x is. Now let's simplify the right side. 2 times x squared, that's 2x squared, minus 2 times 7, that's going to be 14, plus 5. And then combine like terms here, bring down the 2x squared, and then negative 14 plus 5 would simply be minus 9. So this will end up being 2x squared minus 9. And that represents the composition of f with g of x. Alright, problem number 16. Now here we're decomposing this particular function. F of g of x is equal to 5 over the quantity x squared minus 3x plus 6 raised to the 6th power. And we want to find out the functions for f of x and g of x. So we want to know what f of x is and what g of x is. Now notice g of x is on the inside. That has to be the inside function. So we need an inside function that was put in place of x with the g of x. So here we'll use the x squared minus 3x plus 6 as our g of x. That represents the inside function. And then this was put in place of the x here. This was put in place of x. So f of x had to start off as 5 over x to the 6th. So that's what f of x started off as, 5 over x to the 6th, and g of x is your x squared minus 3x plus 6. Alright, number 17. Here we're finding the inverse of a given function, f of x equal to 2x minus 6. And here I want to find out what f inverse of x is. So I'll start off by writing the f of x is equal to 2x minus 6. And there was a 4-step procedure for finding the inverse of any function. So here, first you replace your f of x with a y. So this will be y is equal to 2x minus 6. And then the next step will be to interchange your x and your y. So this y becomes your x equal 2 times, and then the x becomes y minus 6. So you have x equals 2y minus 6. And then we're going to solve this equation for y. So here to solve for y, we need to get rid of the minus 6 by adding 6 on both sides. So we got x plus 6 equals to 2y. And then to get the y by itself, we're multiplying it by 2. So we need to divide both sides by 2. So that means we got y is equal to x plus 6. And all of that's over 2. The final step would be to replace the y with f inverse. So here, this y would be replaced with f inverse of x. And that's going to be equal to this expression right here, x plus 6 all over 2. So this right here represents the inverse of f of x. Okay. All right, problem number 18 is the use of a graphing calculator, and you're going to have a graphing calculator to do this particular type of problem here. Alright, so here this is in 5 parts. Part A, you're going to use a graphing calculator to make a graph of y is equal to 2x squared plus 4x minus 3. Okay, so here, clear this out. Alright, we're going to press the y equal key, which is at the very top of your calculator. And I'm going to clear out these equations that I have here. And if any of your plots are on, you want to hit your up arrow key to highlight, let's say plot 1, or plot 2, or plot 3, and then press enter to clear that plot off. Because you want to make sure all of your plots are off before we do this. Okay, so here we're going to make the graph of y is equal to 2x squared plus 4x minus 3. Okay, so here we're going to type in the 2. There's a button that says xt theta in, so you press your xt theta button for the x. There's an x squared button, so we press the x squared button on the left hand side. So for the 2x squared, then plus 4x minus 3. Plus 4, and then xt theta for the x, then minus 3. Okay, that's going to be your equation. Your screen should look like this. And then you're going to press the zoom key, which is this third key on the very top of your calculator, then select menu item number 6. Because that's the standard window. And this is what the graph of y is equal to 2x squared plus 4x minus 3 looks like. So that was part A that you just done. Part B is to find the two x-intercepts of the function, and you're going to round to the nearest 100 or to 2 decimal places. Okay, so here's what we're going to do here. We're going to press this key, which is the second key, which is the blue key or the yellow key, depending upon which calculator you have. So it'll be second, and then this button that says trace. So second trace will give you this calculate menu. Now we're finding the two x-intercepts, so that means we're finding the zeros of this particular equation. So here we're going to select menu item number 2 for the zeros. And you should get something that says left bound. Now what I'm going to do here is find the first x-intercept right here. There are two x-intercepts, but here I'm going to find the first one right here. Now what I'm going to do is use my left arrow key to position the blinking cursor above that first x-intercept. You want to use your left arrow key to position the blinking cursor above the x-intercept. That will be your left bound. So here we press enter, and after you press enter, you'll get a message that says right bound. Now here you're going to use your right arrow key to position the blinking cursor below that first x-intercept, and then press enter. And then after guess, you're going to go ahead and press enter. And then you're going to get the 0, which is going to be x equal to this number, and then your y should be equal to 0. So here, the x-intercept here would be to 2 decimal places, negative 2.58. And then we got to find the other x-intercept. We're going to use the same thing here. So here we're going to find this other x-intercept right here on the right-hand side. So again, we're going to press the second key and then trace for the calculate menu. And then we're going to select menu item number 2 for the zeros. Now this time, for left bound, we're going to position the cursor below and above. So this blinking cursor needs to be positioned below that second x-intercept, because we're reading this graph from left to right. So here, top to bottom for the first, now bottom to top for this second. So we're going to position the cursor below that second x-intercept, and then press enter. Then for right bound, use our right arrow key to put the cursor below it. Above it, I'm sorry. So below and above for the second x-intercept. And then after guess, go ahead and press enter. Here your x value to the nearest hundredth will be 0.58, and your y is 0. So 0.58 is the other x-intercept. Okay. So that was part B, finding the two x-intercepts. Part C is to find the coordinates of the point where the minimum occurs, and you're going to round to the nearest hundred. In other words, we want the lowest point on this graph. So to get that, we're going to press second and then trace again. This time, under the calculate menu, we're going to select menu item number 3, which says minimum. So we select number 3. And then we want, for left bound, we're going to position the blinking cursor on the left-hand side of the lowest point on that graph. So we're putting the blinking cursor on the left-hand side of the lowest point on that graph, and then press enter. And then for right bound, we're going to position the blinking cursor on the right-hand side of the lowest point on that graph, and then press enter. Then after guess, go ahead and press enter. And that will be your minimum. And you do have to write down both the x and the y values here. So your x will be to the nearest hundredth, negative 1.00. And the y, in this case, that's negative 5. Okay. And I did have to make a correction on this one. This should be D and that should be E. D says, additionally, make a graph of y is equal to x minus 1. Okay? So we press the y equal key at the very top. And we're going to use our down arrow key to go down to y2. And type in x, which is the xt theta button, minus 1. And then again, we're going to press the zoom and then select number 6. For the standard window. That's the graph of the parabola, and there's the graph of y is equal to x minus 1. So that was part D right there. Part E is this. Find the coordinates of the 2 points where the line intersects the curve. Okay, so this graph, the line intersects the parabola at 2 different points, here and here. I'm going to select the one that's at the very bottom that you can see here. And I'm going to find out what the coordinates of that point of intersection is. So here we're going to press the second and then trace. Now here under the calculate menu, we're going to select menu option number 5, which is the intersect, because we want to find out where these two graphs intersect. Now you should get a message that says first curve. Now I'm going to use my left arrow key to position the cursor on top of that point of intersection, and I'm going to try to put that cursor as close as I can on top of that first point of intersection. And then what I'm going to do here is press enter 1, 2, 3 times. That will give me my first point of intersection, and I do have to write down the x and the y values. So here, -2, -3 is the point of intersection. Okay? You must write down your x and your y coordinates here. Now for my other point of intersection, I'm going to go ahead and press second and trace. and select menu item number 5. Now, I'm going to position the cursor on the other point of intersection. I'm going to put that cursor on top of that other point of intersection, and I'll do that as close as I possibly can. Then I'm going to press enter 1, 2, 3 times. That's my other point of intersection here. 0.5 and negative 0.5. So here, 0.5, negative 0.5 is my other point of intersection. Okay. Now, keep in mind on your graphing calculator activities, you did do some problems where you had to find the point of intersection, and you also did some things where you had to find the minimum point and some where you had to find the x-intercepts. So do get some practice over this if you need to. Alright, problem number 19 is a graph of a parabola, and the graph is continued on the next page. So in this case here, we want to sketch the graph of the parabola f of x is equal to x squared plus 4x minus 5, following these steps. The part D will be on the next page. In part A, you're going to find the y-intercept. Anytime you find the y-intercept, you always let x equal 0. So you're going to be evaluating f of 0. And we're going to do that by just simply substituting each x in this original function with 0. So this will be 0 squared plus 4 times 0 minus 5. Then if I simplify this, 0 squared is 0, plus 4 times 0 is 0, and then minus 5. And this will end up being negative 5. So the y-intercept will be negative 5. In other words, that's the point where the graph of the parabola will be crossing the y-axis. Part B is finding the x-intercepts. So here, to find the x-intercepts, you're going to let your f of x, which is a function, that would be equal to 0. And f of x is the x squared plus 4x minus 5. So I'm going to set x squared plus 4x minus 5 to be equal to 0. And then I'm going to factor the x squared plus 4x minus 5 into two binomials here. So this is your x, and that'll be x here. The factors of negative 5, that will give me a plus 4x, will be negative 1 and plus 5. Because minus 1x and a plus 5x will give me the plus 4x. So this is x minus 1 times x plus 5 equals 0. Now x minus 1 times x plus 5 equal to 0 means this. X minus 1 equal to 0, x plus 5 equal to 0. And then each equation I'm going to solve for x. So for the x minus 1 equal to 0, that means x is equal to positive 1. And then for the x plus 5 equal to 0, that means x is equal to negative 5. So my two x-intercepts are at 1 and negative 5. That means that the graph of that parabola will be crossing the x-axis at 1 and at negative 5. Alright, part C is finding the coordinates of the vertex. Now we're going to use that formula of x equal negative b over 2a. That's the formula for the x-coordinate of your vertex. If you recall, that's always x equal negative b over 2a. Now, let's find out what a is. The a is the coefficient of your x squared term. That's 1. B is the coefficient of your x term. That's going to be 4. So we're going to use that to find out the x-coordinate of the vertex using this x equal negative b over 2a. So here, b is 4, so this will be negative 4 in the numerator. The denominator will be 2 times a, which is 1. Now let's simplify this. This will be negative 4 over 2 times 1, which is 2. Negative 4 divided by 2, that's negative 2. So I know my x-coordinate of my vertex will be negative 2. Now the y-coordinate of the vertex, I need to find that out by substituting negative 2 in for x. So each x in the original function, I'm going to substitute negative 2 in its place. So it'll be negative 2 squared minus plus 4 times negative 2 minus 5. And in this case here, negative 2 squared is negative 2 times negative 2, which is 4. And then 4 times negative 2, that's going to be minus 8, minus 5. Now in this case here, 4 minus 8 would be negative 4. Negative 4 minus 5 will end up being negative 9. So the y-coordinate there will be negative 9. So the ordered pair for that vertex will be negative 2, negative 9. Okay, now I'm going to use all of this information to do the graph on the next page. Because you're going to use these points and a point symmetric to the y-intercept with respect to the axis of symmetry of the parabola to sketch the graph of that parabola. Okay, the y-intercept in this case we found out to be negative 5. So we're going to go down to negative 5 on the y-axis and draw the point. The x-intercepts are 1 and negative 5. So here on the x-axis, I'm going to draw a point at 1 and a point at negative 5. And then my vertex was negative 2, negative 9. So here I go to the left 2 and down 9 and draw the point. And I'm going to go ahead and draw in the axis of symmetry. If you recall, the axis of symmetry is the vertical dotted line that goes through the vertex. So in this case, here's my axis of symmetry. Goes through the vertex. And that axis of symmetry is x equal negative 2. And that comes from the x-coordinate of your vertex. Now, to come up with an additional point, compare the distance from this y-intercept to this axis of symmetry. That's 2 places to the right. So the other point on this side must be 2 places to the left. So it's going to be here. And it'll have the same y-coordinate as my y-intercept. So these are all the points that I'm going to need to draw the graph of the parabola. And it looks like this. So this represents the graph of the parabola. F of x is equal to x squared plus 4x squared plus 4x minus 5. F of x equal to x squared plus 4x minus 5. Okay. Alright, problem number 20. Here we're going to use the synthetic division and the remainder theorem to evaluate the function f of x is equal to x cubed minus 2x squared minus 29x minus 42. And we're going to do that for x equal to negative 5. Okay, using the synthetic division, my x equal to negative 5 will be the divisor. Now for the f of x equal x squared minus 2x squared minus 29x minus 42, notice that there are no missing terms here. We got x cubed, x squared, x, and a constant. So we can write down the numerical coefficients. The coefficient of x cubed is 1. For the x squared, its coefficient is negative 2. For the x, that coefficient is negative 29. And then the constant is negative 42. So here if I bring down the 1, which is the leading coefficient in the bottom row, now I'll take that 1 multiplied by the divisor of negative 5. 1 times negative 5 will be negative 5. And then add negative 2 to negative 5, you're going to get negative 7. Then multiply negative 7 times negative 5. That's a positive 35. And then add negative 29 to 35. You're going to get 6. And then finally, 6 times negative 5 will be negative 30. Negative 42 plus 30 will be a negative 72. Now, in synthetic division, the last number in the last row represents the remainder. And for the remainder theorem, here, that remainder represents the value of that particular function f of x when x is equal to negative 5. So I can conclude that f of negative 5 would be negative 72. And you would get the same f of x value if you replace the x with negative 5 in the original function f of x. Okay, problem number 21. We got this. We're going to use the rational zero theorem and the synthetic division process to find the zeros of the function f of x is equal to x cubed plus 8x squared plus 11x minus 20. And you're given that negative 4 is a zero of that particular function. Okay, so here, negative 4 will be our divisor. Now here we have no missing terms here. We got x cubed, x squared, x, and a constant. So we write their numerical coefficients down. For the x cubed, that coefficient is a 1. For the x squared, that coefficient is 8. For the x, its coefficient is 11. And then the constant is negative 20. Okay, so now we bring down the numerical coefficient, the leading coefficient in the bottom row, which is your 1. And then we multiply 1 times our divisor of negative 4. So 1 times negative 4 will be negative 4. 8 plus a negative 4 is 4. And then 4 times negative 4 is negative 16. Add 11 to the negative 16, you're going to get negative 5. And then negative 5 times negative 4 is 20. Negative 20 plus 20 is 0. So I would expect to get a remainder of 0 because 4 is a 0 of that function. Okay? And since 4 is a 0 of the function, I can say that x minus whatever that constant is, and in this case is negative 4, so it'll be x minus negative 4, or x plus 4 is a factor of that polynomial function. Okay, now I'm going to set that f of x function equal to 0. So this is x cubed plus 8x squared plus 11x minus 20 equaling to 0. Now I know x plus 4 is a factor, so I'm going to write down the x plus 4. The other factor is this quotient right here that you see at the bottom. The quotient is always one exponent less than the highest exponent of f of x. So if f of x started off as x cubed, the 1 would be your coefficient of x squared. Plus the 4 is the coefficient of x, and then minus 5 is your constant. So here I got x plus 4 times x squared plus 4x minus 5 equaling to 0. Now this can be factored into two binomials here. So I'm going to bring down the x plus 4, and I'm going to factor x squared plus 4x minus 5 into two binomials. So here that x squared would be x and x. The factors of a minus 5 that will give me plus 4x will be minus 1 and plus 5. So this is x plus 4 times x minus 1 times x plus 5 equaling to 0. Now I'm going to set each binomial factor equal to 0. So this means either x plus 4 equals 0, or x minus 1 equals 0, or x plus 5 equals 0. And then I'm going to solve for x here. So for the x plus 4 equals 0, that means x is equal to negative 4. For the x minus 1 equal to 0, that means x is equal to 1, or for x plus 5 equal to 0, that means x is equal to negative 5. So in this case here, your three solutions are x equal negative 4, x equal 1, or x equal negative 5. So here we can say negative 4, 1, and 5. And they don't have to be in any particular order. Okay. All right, problem number 22. Here we're going to use the Gauss-Jordan elimination to solve the system. Here we got 3x minus 4y equal to 11, and 2x plus 3y is equal to negative 4. Okay, in this case here, you're going to use the graphing calculator to do this. In class, I showed you how to use the reduced row echelon form on your calculator to come up with your x and your y values. But on the test, I would expect for you to write this as an augmented matrix. Okay, in the first column is your coefficients of x, which are right here, 3 and 2. That goes in the first column. The second column is your y coefficients, and that's these numbers right here, negative 4 and 3. And then your constants will be behind the vertical bar, which represents your equal sign, 11 and negative 4. Okay, so here's where we use our graphing calculator to do this. Okay, clear this out. Okay, the way we do this is we press second and then your x to the negative 1 key for your matrix. Second, x to the negative 1 for the matrix. Now we're editing this new matrix here, so we're going to use our right arrow key to highlight edit, and then we're going to put this in matrix A. So we'll select number 1 for matrix A. Now in this case here, these two numbers here represents the dimensions of that matrix. Here, rows and columns. It's a 2-row, 3-column matrix. So we're going to enter the 2 for the row and the 3 for the column. And then that cursor will take you to the first row, first column. You're going to enter each element row by row, pressing enter after each number. So like in this case here, we're going to press the 3, enter 3, and then enter. Then negative 4, enter. And then 11, enter. Then we enter the second row. 2, enter, 3, enter, negative 4, enter. You have to press enter after each and every element, including the one in the last row and the last column. And then we press second and mode to get out of it. And then the next thing I'm going to do here is second, x to the negative 1, and then use my right arrow key to highlight the math menu. And then I'm going to use the down arrow key to find the menu item that says RREF. That's the abbreviation for Reduced Row Echelon Form. So highlight that and you're going to press enter. Now I need to retrieve that matrix that I entered in. So let's press second, x to the negative 1. And under the names menu, we store that in menu item A, number 1, which is A. So let's select number 1 for matrix A, and then close your parentheses, and then hit enter. Now this is the output that I would expect for you to write on your test, which is 1, 0, 1, and then 0, 1, negative 2. And that's with the vertical bar here. Now let's explain. Let's see what this last column represents. The last column represents the ordered pairs for x and y. This is your x, that's your y. Here x is 1, y is negative 2. Okay, so as the final answer, X is equal to 1, Y is equal to negative 2. And that's pretty much all you have to do on here. So when you show your work, you have to write this as an augmented matrix, and then use your calculator to come up with this output right here, which I will expect for you to write down, and then write down what X is and what Y is. Okay. Problem number 23 is using Cramer's rule to solve this system of linear equations. Here we got 4x plus 3y is equal to 15, and 2x minus 5y equaling to 1. So in this case here, we need d, and we also need d sub x, and we also need d sub y. Okay, because you have to have 3 matrices here. And you're going to find 3 determinants here. Your d is always going to be the x and your y coordinates here. Coefficients, I mean. X and your y coefficients for your d. Here's your x coefficients right here. 4 and 2. The y coefficients here are 3, negative 5. Now d sub x, instead of your x going in the first column, it's going to be your constants. The second column is your y. So your constants are right here, 15 and 1. And then your y coefficients are 3, negative 5. And then d sub y. First column is your x. The second column, instead of your y's, is going to be your constants. So your x column of coefficients will be 4 and 2. And then your constants are 15 and 1. So now we're going to find the determinant of all 3 of these matrices here. So here, starting with the d, that determinant will be the product of this first diagonal from the upper left to the lower right minus the product of the second diagonal from the lower left to the upper right. So here, start with 4 times negative 5, that's negative 20, minus 2 times 3, that would be 6. Now if you do negative 20 minus 6, that will give you negative 26. So your d is going to be negative 26. Now for d sub x. This diagonal, 15 times negative 5 will be negative 75, minus this diagonal, 1 times 3 will be 3. And then negative 75 minus 3 will be a negative 78. So your d sub x will be negative 78. And then for d sub y, 4 times 1 will be 4, minus 2 times 15 will be 30. And then 4 minus 30 will be negative 26. So d sub y is negative 26. Now we're going to use d sub x, and d sub y to find out what x and y are going to be. X is always d sub x divided by d. So here your x is negative 78, d sub x is negative 78, your d is negative 26. So negative 78 divided by negative 26 would be a positive 3. And then your y is d sub y divided by d. So d sub y is negative 26. Your d is negative 26. Negative 26 divided by negative 26 would be positive 1. So x is 3 and y is 1. So the solution of this system of linear equations will be the ordered pair 3, 1. Okay, so that's how we apply Cramer's rule to that particular problem. Alright, problem number 24 is finding a determinant of a 3 by 3 matrix. Okay, but here you have to use the method that was shown to you in class. So here we got 3, negative 2, 1, 2, 4, 3, negative 1, 5, 1. So here I'm going to go ahead and rewrite that matrix here. I'm writing this in column form, column by column. Okay. Now, the way we do this, finding the determinant of a 3 by 3 matrix, is to rewrite the first two columns of this matrix. So here, I'm going to write the 3, 2, -1, that's the first column, and then -2, 4, 5, that's the second column. I'm rewriting the first and the second column here. Now, here's how I find the determinant. I'm going to take the product of these diagonals going from the upper left to the lower right. And there are three of them that I'm going to find. Starting with this one, the 3, 4, and the 1, if I do 3 times 4, that's 12, times 1, that will be 12, plus the product of this diagonal here, -2 times 3, that's -6, times the -1, that will be 6. And this one, 1 times 2, that's 2 times 5, which will be 10, and that'll be plus 10. So I'm taking the sum of the products of each of these diagonals from the upper left to the lower right. Now I'm going to subtract the product of each diagonal going this way from the lower left to the upper right. So here I'm going to start off with a minus sign. This product, -1 times 4, that's -4, plus 1, which is still going to be -4. And then minus the product of this diagonal, the 5, 3, and 3. 5 times 3 is 15. 15 times 3 will be 45. That'd be minus 45. And then minus the product of this diagonal right here, 1, 2, and -2. 1 times 2 is 2. 2 times -2 would be -4. Okay. Now I'm going to simplify this a little bit. I'm going to go ahead and write down the 12 plus 6 plus 10. Now minus the -4 will be plus 4, and then minus 45, and again minus the -4 will be plus 4. And this I can enter into the calculator by doing 12 plus 6 plus 10 plus 45 plus 4 minus 45 plus 4. And that will end up being -9. So in this case here, the determinant of that 3 by 3 matrix will end up being -9. Okay. Alright, problem number 25 is using the change of base property to find log to the base 3 of 17. Log to the base 3 of 17 using the change of base property. And in this case here, if you recall the change of base property, I write this down, log to the base b of m. Using common logarithms, it would be the log of m divided by the log of the subscript of your log, which is your b. And this also works for natural logarithms as well. This could be ln of m divided by ln of b. So in this case, log to the base 3 of 17 would be the log of that number, which is 17, divided by the log of this subscript, which is your 3. So here I'm using common logarithms to simplify this, or to evaluate this. Now we're going to round to the nearest hundredth. So in this case here, I'm going to press the log key for the log, and then type in 17, close your parentheses around the 17, because you only want the log of 17. Then whatever that is going to be divided by the log of 3, close parentheses. So your screen should look like this, and then go ahead and press enter. So in this case here, this will be 2.58 if we were to round it off to 2 decimal places. So log to the base 3 of 17 would be 2.58. Okay. All right, number 26 is expanding this logarithm in terms of log of m, log of n, and log of p. So here we got the log of p to the power of 9, log of p to the 9th, times the 4th root of n. All that's over m to the 5th. So in this case here, right off the top I see a numerator and a denominator, so I know I need to take I have to apply the quotient rule because I have the log of the quotient. That can be expanded as the difference of their individual logarithms. So this will be expanded as log of p to the 9th times the 4th root of n, minus the log of m to the 5th. Okay, because it's the log of the numerator minus the log of your denominator. Here I'm applying the quotient rule. Now, this one right here, this term right here, that's a time sign between p to the 9th and the 4th root of n. So that's the log of a product. I can expand that as the sum of their individual logarithms. So log of p to the 9th times the 4th root of n would be expanded as log of p to the 9th plus the log of, and I'm going to go ahead and change the 4th root of n to its exponential form, n to the 1/4. I'm applying the rule where you have the nth root of a to some power of m, bring over the a, your m will be the numerator, and your n, which is your index, that's your denominator. So the 4th root of n will be n to the 1/4. And then I'm going to bring down the minus log to the base, log of m to the 5th. Okay, now, one last thing I need to do. Each one of these has exponents. I can apply the power rule on each of these three terms. So in this case here, that 9 will become the coefficient of log of p. So it'll be 9 log of p log p plus this exponent of 1/4 becomes the coefficient of log of n minus this 5 becomes the coefficient of the log of m. So log of p to the 9th times the 4th root of n divided by m to the 5th will be expanded as 9 times the log of p plus 1/4 the log of n minus 5 log of m. Alright, number 27 is a logarithmic equation that you're going to have to solve, and you'll have to check your proposed solutions here. Here we got the log to the base a of x plus 4 plus log to the base a of 6 equaling to log to the base a of 42. Now in this case here, I see a plus sign in between. That means I have the sum of their individual logarithms. I need to condense that as the log of the product. Okay, so here it will be log to the base a of, and I'm going to put the 6 in front of x plus 4. And then that's equal to the log of to the base a of 42. Okay, so you first have to condense each side as a single logarithmic expression using either the product rule, the quotient rule, or the power rule. And I had to condense this using the product rule. Now I'm going to use the one-to-one property that states if log to the base b of m equals log to the base b of n, then m equals n. So here, I'm going to set this 6 parentheses x plus 4 to be equal to this number, 42. So all I need to do here is go ahead and solve for x. So here, using the distributive property, this will be 6x plus 24. 6 times x, that's 6x, and then 6 times 4 will be plus 24, equal 42. And then I need to get the 6x by itself by subtracting 24 on both sides. So that means I'm going to have 6x is equal to 18. Divide both sides by 6. X is equal to 3. Now that's the proposed solution, but you have to do the check. Now to do the check, you use your original equation and replace the x with 3. So this will be log to the base a of 3 plus 4 plus log to the base a of 6 equals log to the base a of 42. Now 3 plus 4 will be 7, so this will be log to the base a of 7 plus log to the base a of 6 equaling to log to the base a of 42. Now again, the sum of your individual logarithms is condensed as the log of the product. So this will be log to the base a of 7 times 6 equaling to log to the base a of 42. Now if you multiply 7 times 6, you will get 42. So log to the base a of 42 equals log to the base a of 42. So I can conclude that x equals 3 is the solution to that logarithmic equation. Okay. Number 28 is another logarithmic equation where you have to check your proposed solutions as well. And in this case here, you got log to the base 6 of x plus 5 minus log to the base 6 of 7 equaling to 2. Okay. First of all, we need to condense the left side as a single logarithm. Here we got a minus sign, so we need to apply the quotient rule. That's the difference of the natural logarithms, is equivalent to saying the log of the quotient. So here this will be log to the base 6 of x plus 5 over 7 equaling to 2. The difference of the individual logarithms is condensed as the log of the quotient. Now, I only have the log on one side of the equation, so that means I need to convert this to an equivalent exponential form, meaning this base is your 6, the 2 will be your exponent for the 6, and that will be equal to the x plus 5 over 7. So in this case, this will be written as 6 to the second equal to x plus 5 over 7. Now let's simplify this. 6 squared, or 6 times 6, that's 36, is equal to x plus 5 over 7. Now, I need to get rid of the 7 in the denominator, so what I'm going to do here is multiply both sides by 7. That way, these 7s divide out on this side, and then 7 times 36 will be 252, and that's equal to x plus 5, or x plus 5 equals 252. Now I can easily get x by itself by subtracting 5 on both sides. So that means here x is equal to 247. So x equals 247 is the solution to that, or the proposed solution to that logarithmic equation. I had to do the check to confirm it. Using the original equation, I replace the x with 247. So I have log to the base 6 of 247 plus 5 minus log to the base 6 of 7 equaling to 2. 247 plus 5 is 252, so the log to the base 6 of 252 minus the log to the base 6 of 7 should equal to 2. Now again, I have the difference of their logarithms. I can condense that as the log of the quotient. So this will be log to the base 6 of 252 divided by 7. And that's equal to 2. Now if I do 252 divided by 7, that should give me 36. So log to the base 6 of 36 should equal to 2. And then if I convert that to its equivalent exponential form, this will be 6 to the second equal 36. And if I do 6 to the second, I would get 36. So 36 does equal to 36. So here x equals 247 is the solution to that logarithmic equation. Alright, problem number 28. It's an exponential equation. You got 10 to the power of x minus 7 is equal to 18. And we're going to round the answer to the nearest hundred, or to 2 decimal places. Now notice, normally I would take the natural log on both sides, but I have a 10 here, a base of 10. So instead of taking the natural log on both sides, it'll be easier to take the log on both sides. So I'm going to take the log on both sides of this equation. So I have the log of 10 to the x minus 7 equaling to the log of 18. Now, there is a property that says if you have log of 10 to whatever your exponent is, that will be your exponent. So log of 10 to the x minus 7 is x minus 7. And that's equal to the log of 18. Now I'm going to get the x by itself. I'm subtracting 7, so I'm going to add 7 on both sides. So I have x is equal to, now here I'm going to put the 7 in front of the log of 18. And then I'm going to use my graphing calculator to come up with the approximate value of that x value here. So here we type in 7 plus, press the log key, and then 18. Close your parentheses. And then I'm going to hit enter. Now the 2 decimal places are to the nearest hundred. This will be 8.26. So my x value here will be approximately 8.26. Okay, then finally number 30. How long will it take for $5,000 to grow to $7,500 if the principal was invested at 7% annual rate interest compounded continuously? Round your answer to the nearest tenth. So the principal is the $5,000. Your A, that's the amount that we want to reach, is $7,500. And your interest rate is 7%. As a decimal, that would be 0.07. And you're told that it's compounded continuously. So we have to use the continuous compounding formula, which is going to be A is equal to P times e to the RT. A is equal to P times e to the RT. And your P in this case is your 5,000. Well, P is $5,000. A is 7,500. So let's substitute the A with 7,500. Your P is 5,000 times e to the R. That's 0.07 times t. T is what we're trying to find. So you have 7,500 is equal to 5,000 e to the 0.07 t. I do need to get the exponential part by itself. That e to the 0.07 t is being multiplied by 5,000. I need to divide by 5,000 on both sides. So here this will be E is equal to 0.07t, and 7,500 divided by 5,000 would be 1.5. So I got 1.5 equaling to e to the 0.07t. Now since e and natural logarithm are inverses, I'm going to take the natural log on both sides of this equation. And in this case here, if you have ln of e to whatever this exponent is, it is that exponent. So ln of e to the 0.07t would be 0.07t. Then that would be equal to the ln of 1.5. And then to find out what t is, we divide by 0.07 on both sides. So here I'm going to find out what t is. Using my graphing calculator, type in ln and then 1.5. Close your parentheses around the 1.5. Then whatever that is divided by 0.07. Then hit enter. Enter the nearest tenth would be 5.8. And the time is in years, so it'll be 5.8 years. So it's going to take 5.8 years for a $5,000 investment to grow to $7,500 at 7% compounded continuously. Okay, so that is what would be similar to what you will see on your final exam. And you may email me if you have any additional questions, or come by my office if you need additional assistance.